Good day, class.
Good days.
How are you today?
Yeah, fine.
I'm also great, class. I'm great. Oh, we've come to the best class, I believe, the most fun class, which is the physics class. So guys, I would like to introduce something to you today. I have a very interesting topic, right? So now, what I wanted you to just zone out of this classroom, think about the park, right? Think about the park, whereby we have our merry-go-rounds, we have our seesaws. Do you know what a seesaw is?
Yes, sir.
Okay. Do you know what a seesaw is?
Yes.
Keko. That's a big. Huh? Gingakongo. That thing that goes like that, like a scale. Yeah, well. So we have that, right? So let's say we have that, right? There's your gingakongo and your seesaw, right? So now on this side, we have a person. Let's say you weigh 70 kgs, right? And then on this side, let's say I'm on this side, you're on this side, and then I weigh 50 kgs. Okay, let's just say 35. Let's say 35 kgs. I know that's almost impossible for a person this size, but for reference's sake. So what's happening is now you need to maintain balance, right? So I need to maintain what we call balance or a balance. Like I need this to be the same as that, or this to be the same as that, right? So now what's happening is here, what I need to do in order to maintain that balance, because we need to be on the same level or the same standard, right? So now I need to multiply that by 2. I can get another person who is 35 kg that will join me, and then in that way there will be balance, right? So guys, what do you understand about the word balance or balance? What do I mean by balancing?
Things have to be equal.
Equal, right? Exactly. So today, it's like having. Thank you so much for that. So it's like having a couch, right? So on one end of the couch, there's the couch. Please do not mind my drawings. I wasn't really good at drawing. So we have you on this side, and I have me on this side. And now, what we actually find is that the couch is falling, right? Because you are heavier than me. So as viewer said, it's a matter of maintaining balance or being equal. So in that case, I need someone, which Unam in this case, that will come and maintain that balance. Our Crystal. So, okay, moving along guys. So today, basically I was talking about balancing, and we talked about things being equal when we're balancing, right? So balancing, today we'll be balancing equations. Today we'll be balancing equations. Okay, this was just a scenario whereby you need that scenario in order for you to be on board with this. So basically when it comes to balancing equations in chemistry or in physics, what we need is, you'll find that you'll have a left-hand side and you'll have a right-hand side. As the viewer earlier said, it's a matter of having equal things, right? Or equal sides. So in this case, the reason why we're learning this is mainly because we want to have a left-hand side that is equal to the right-hand side. Are we crystal on that?
Yes.
No problem. So now, why do we balance? It's a matter of, we have what we call the conservation of atoms and mass, right? In physics or in chemistry, both. So what does it say? It says that mass or matter can neither be created nor destroyed, but it can be transformed from one form to another. What does that mean? It means that if on this side you had a mass of 2 kgs, right? On the right hand side, or after the reaction, you are expected to have 2 kg, right? That's what we are trying to maintain basically in this case. So you're probably asking yourselves, why am I introducing the laws of conservation of mass and everything? It all has to do with what we call physical and chemical change. Sorry for that. Physical and chemical change. Remember, I taught you this in grade 9 last year, whereby I taught you about physical change, whereby a new substance is not formed, right? So if, for example, we had a block of ice, right, and we expose that block of ice into heat, right? We expose that block of ice to heat, and then that block of ice melts into a liquid, right? Mind you, the water did not change, right? So there is no new substance that is formed. It just changed the what we call the states or the phases. So it moved from an ice to water or liquid. Are we crystal? Okay, but now we're not dealing with physical change. As I said, I taught you these 2 concepts last year. It was physical and chemical change. So chemical change, there's a new substance that is formed. So for example, if you burn wood, right? Or you burn oil. Let's say you burn oil, there will be a new substance that is formed, right? So when you burn wood, you'll be expected to get carbon dioxide. Is there? It is possible. And water, right? And water, H2O. Now, guys, I cannot emphasize this any further. So you need to know how to write your chemical formula, right? Or chemical formula. This is a chemical formula. In some cases or in some instances, what they do is, sorry for that, what they do is they give you the name, right? And they say plus, let's say oxygen. Okay, let's say oxygen. This is just an example, guys. Carbon dioxide, like that, right? So what you need to do when you're balancing, you need to be sure of how to change from chemical name to the chemical formula. This is a chemical formula, this is a name, right? So we know, as I told you last year, again, hopefully the December or the holidays did not mix you up, guys. So water can be represented as H2O. I believe, is there anyone who doesn't know that? I told you, right? Okay, thank you so much. So, and then oxygen is a diatomic atom, right? So it can be represented as O2, right? And then that is carbon dioxide, like that. So guys, basically, having to balance chemical equations, it has to do with balancing, remember what I said, the left-hand side, of which the left-hand side is whatever that is behind the arrow. Do you see the arrow? It's whatever that's behind the arrow, which is this. Then, whatever is after the arrow, that is the right-hand side. So now we'll be dwelling much on that, or diving into it, where we'll be balancing this and this, so that they can have equal mass. Okay guys, I do have a few, are there any questions?
Yes.
No questions at all. You're fine.
Crystal.
Clear. You're supposed to be clear though. Okay, no problem. Okay guys, I need someone who's gonna have the boat with me next time. I need someone who's gonna have the boat for me. So guys, I have this formula, which is C3H8, right? It's the combustion, O2, right? Then it's CO2, H2O, CO2 plus H2O. Now, diving into it, we have that, right? Remember what I said. We have a left-hand side and a right-hand side, right? Now, from there, how can you balance this? You're probably asking yourself the question, so how do we balance that? How do we ensure that it's balanced or not? So I introduced to you the 4 steps of balancing equations. I call them the Fantastic Four, whereby these are the steps that you need when you get an equation, right? So the first step is you need to balance all the metals. Balance all the metals. How do you balance all the metals? Remember guys, I already sent the periodic table to you in the group chat, where I believe it's in front of you now. Thank you for having your phones on silent. So what's happening there in your periodic table, you'll find that you have an element of which is element 5, which is boron. Can you see it next to carbon? It's B on the first. Thank you. So from boron, you can do what we call a stepped line, right? A stepped line like that. You find that that is B, right?
Yes.
And then on this side of your periodic table, that's where you find your metals. All of this from here, under the stepped line, to the left hand side, those are all your metals, our crystal.
Yes.
Okay, except, listen to that, except for hydrogen, because hydrogen is a non-metal. Hydrogen is very picky, it's very unique. Let me just put it that way. So, on your right hand side, you're probably asking yourself a question, you find your non-metals. So, on your right hand side, on your left hand side is your metals, on your right hand side it's your non-metals, our crystal.
Yeah.
Thank you so much. So now, okay, I said using the Fantastic Four, balance all the metals, right? Meaning everything from beneath the stepped line to the left, that's what we balance in this chemical equation. Now, let's look at it, guys. Can you see any metals? Is C, which is carbon, a metal? No, right? Okay. So H is not a metal, we already said that. It's a non-metal. Oxygen is not a metal. It's a non-metal because it's on the right-hand side. So now, okay, we don't have metals. So what do we do then? We go to step number 2. Step number 2 says balance all the non-metals except for hydrogen and oxygen, our crystal.
Yeah.
Okay, so except for hydrogen and oxygen. So now, okay, hydrogen and oxygen we don't look at because we won't, in this step we don't look at them. So we're looking at carbon. Carbon, okay? Carbon has 3 atoms, right? That's the left-hand side. Now, we look at the right-hand side. Carbon has 1, right? Can you see, guys? Oh, sorry for that. So now, what can we do to balance, to make this be equal to that, or this be equal to that?
Add 2.
We add 2, okay. Thank you, correct. So, what's happening is, when it comes to chemical equations or formulae, we don't add, right? We only multiply. Remember, I told you this last year again. Addition and multiplications are cousins. They are cousins, they are similar. So basically from a small number to a big number. So now, what can we multiply? That's the correct question. So I was wrong, you were right. Because you answered what I asked, right? So what can we multiply in order to get that? What can we multiply 1 by?
3.
1 multiplied by 3. Thank you. Now, how do we represent that? We multiply by 3. How do we represent that? Listen, guys. What I need you to note or state, or keep in mind rather, isolate these like that. Isolate them like that. Why, sir, you're saying we must isolate them? I'm saying you must isolate them because whatever is given, guys, you don't change. Whatever equation that is given, you do not change these. You do not put in any number, you do not manipulate them. The only time that you change them is when you multiply by something. So that number, you need to indicate in the given equation that you multiplied by it. So how do you indicate it? Okay, so you said you must not change it, but now you're saying you must illustrate it. What are you actually saying? So by multiplying by 3, remember guys, that's the left hand side. This is the right hand side. So on the right hand side, you multiply by 3, right? By multiplying by 3 at C, which is carbon, so you need to indicate that there, right? So you don't write it as a subscript or as the small number. There, you write, or there, you write it as a coefficient in front. Let's just, in front of the box. Let me just put it that way. So, after you multiply that, okay, now we have C3 and C3, which is left hand side is equal to the right hand side. Now what can you do? You need to go to the next step. What is the next step? The next step says balance hydrogen. Okay, balancing hydrogen, we look at hydrogen on the left hand side, it's H8, right? And then on the right hand side, it's 2, right? Can you see that? 2. So it's 2. Now, ask yourself the question, what can you multiply 2 by in order to get 8? By 4. Very good. Guys, you're gonna pass. 8. I can feel it. I can feel it. Oh, distinctions. Okay, guys. Now, you multiply by something. Remember that. Now, after multiplying, you need to show in the given equation that you multiplied. Right? So, how do you do that? You put the 4 that you multiplied by in front of the box. That is correct. So now, okay, so now we're moving on to oxygen, right? Because hydrogen and carbon is balanced, and carbon did not change when we changed hydrogen, right? So now, oxygen on the left-hand side, 2, right? Is that correct? And then oxygen on the right-hand side, that's 3 multiplied by the 2, which is 6, plus that 4 multiplied by the 1. If there's nothing, it's a 1. So it's 3, that coefficient or the number in front of the box, multiplied by whatever is inside the small number or the subscript, that is 6, plus 4, the number behind the box, multiplied by that. So it's 3 times 2, which is 6, plus that 4. So it's 6 plus 4, which is 10. Now, sir, uzenenye, sir. Okay, it's 2 and 10. Guys, you don't necessarily need to always multiply a number on the right hand side only. You can balance on the left hand side in order to get equal sides. So now in this instance, we have 10 on this side and we have 2 on this side. So what can we multiply 2 by in order to get 10?
5.
Which is 5 multiplied by 5. Okay, you guys Nina. Okay, so now you multiply by 5. You need to indicate that in the given equation. Remember that. So now that 5, you write it there in front of the box. There, guys, you have your balanced equation. Okay, so how do you know that it's balanced? You're probably asking yourself that question. Guys, can you look at your periodic tables? On your periodic tables, we have C. Look at C. C has a small number and a big number, right? So, give me the big number. Give me that big number. C.
6.
Is it 6?
The big one.
Yes, the big one.
12.
12.
0, 1, 1.
It's 12. Yeah, let's just round it off. We say 12. Okay. Where am I getting with this? 12. We call that number the mass number or the atomic mass, right? So the 12. Then what is H? The big number for H? It's 1, right? Okay. 1. And then what is the big number for O, or oxygen?
59.
Okay, let's just round it off to 16. Okay, interesting. So what are you getting to? Where are you getting to? Okay, now guys, what you need to do is you need to take the small number multiplied by whatever's there, then multiply by that. I'm not sure whether you follow me. So you just multiply that by 3 because the molar mass or the mass number of carbon, or C, is 12, right? In order to check whether the left hand side is equal to the right hand side, you take that mass number, which is 12, you multiply it by that number, that small number, which is there, right? Now you add, right? That number multiplied by that, it's 8, right? So 1 multiplied by 8 in brackets, and then 16 now there. I said the small number multiplied by that, which is 10,
10.
right? Oh, that's a large number though. Times 10, like that. And then on this side, right? We can just solve that. I'll just solve it quickly because I know if I ask you, you'll just, I believe you'll just waste time. 36 plus, of which I believe you're already hungry. 8 plus 160. And then on the right hand side, what do we have? We do the same thing on the right hand side. Now it's 3 multiplied by that one, which is 3 times 12, which is 3 times 12 on that side. And then 3 times 6, 3 times 2 I mean, it's 6. And then plus 6 times, what is the mass number for oxygen? That big number for oxygen? 16, right?
Yes.
15,9. Okay, that's 16. And then plus 4 times 2, 8 times 1, because the big number for hydrogen is 1. Okay. Then for oxygen again, 4 times 1 is 4. So it's 4 times 16 again. Now I'll just simplify that for you. It should give me the same answer though, or the same value. 3 times 12 plus, okay, let me just say 36. 36 plus 16 times 6 is 96. 8 plus 8 plus 16 times 4 is 64. Okay. 96 plus 64 plus 8 plus 36. This is 204. What about this one? 36 plus 8 plus 160. That's how you maintain balance. So guys, later this year, I'll be teaching you about moles, but we're not there yet. So this is how you just maintain the balance, or you ensure that balance is maintained. So you can see that it's 204, and you can see that it's 204, of which it means that your equation is balanced. Guys, I would like to give you another one, just for practice, to see whether you would have grasped the concept or not. Guys, I need a boy. It's usually a boy's job, isn't it? Okay, so guys, I'll just be quick on this one. Like, it's just one, and then we'll be out. Or I'll just give you your favorite break, favorite exercises. You guys like to exercise, right? Or do you like fruit? Do you like fruit or exercises?
Food.
Food. Okay, what's your favorite food?
Fast food.
Pizza, definitely. Burgers. Okay, it's fine. I'll just give you a burger after the lesson. I'll give you the pizza after the lesson. What about you guys? What about the others? Same, eh? Okay, no problem. I'll just give you that fast food fast. Okay, now guys, we have that, right? Look at K. look at Br, which is bromine, look at KBr, right? So guys, now, what you need to know in this case is, remember we're following the Fantastic Four. Fantastic Four says balance all the metals. First thing, put your box so that you do not change them or you do not manipulate anything there, right? Now, balance all the metals. Now, what is the metal in this case on the left-hand side? I believe K is a metal,
Yes.
which is potassium. So now, K on the left-hand side is 1. Am I correct? Now, what is K on the right-hand side? K on the right-hand side is also 1. So it's balanced already. That's fine. Are we crystal?
Clear.
Now, we're looking for non-metals, except for hydrogen and oxygen, right? So now, non-metals on the left-hand side, it's bromine. Yeah, Br, right? Br on the right-hand side is 1, right? Can you see that? And then on the left-hand side, on the right-hand side, it's 1. Is that correct? It's already balanced though. Isn't there something wrong? I feel like there's something wrong. Bromine is a diatomic element in this case. Yeah, it's a diatomic element. So in this case, it should be 2, right? Sorry for that. It should be a 2. So now on the left-hand side, we have a 2, but on the right-hand side, we have a 1, right? So what do we need to do? We need to ensure that we multiply this by something in order to get that 2. What do we multiply 1 by in order to get 2?
2.
By 2, right? That's correct. You guys, you're gonna pass, I can feel it. Maybe we're writing a test tomorrow. I can feel it, you guys already know this. Okay, so now remember, the number that you multiply by, you put it in front of the box, or yeah, before the box. Okay, now we can just see or verify that we got the correct balance equation. Balanced equation, so give me the mass number of potassium, or the big number. Isn't it 39?
39.
It's supposed to be 39, yes. Plus, what is bromine?
70. 79. Sorry, 80.
Okay, it's 80. So it's 80 times that 2. Remember that 2. Now, okay, now here, it's that 2 times 39 plus, the minute you jump from one element to the next, you add. But the minute you're sticking with one element, you multiply. Remember, multiplication is the cousin of addition. So now 2 times 80. Trust me guys, it will give you, that is 160, 39, that is 199. On the right hand side, it's 160 plus 39. Aye?
So
Yes?
the problem is we have hazy.
Oh, yeah, hey, you see, that's the catch. Guys,
It's not
we
balanced.
did not balance potassium because the minute we put the 2, we needed to go back to metals, because now on the right hand side we have 2 because we multiplied by that, right? So this accommodates that and this accommodates that. So now we have a 2 on the right hand side, but we have a 1 on the left hand side. Now what do? We multiply by 2, right? And then we put that 2 there, which will give us, what is 39 times 2, guys? 39 times 2? Okay, it's 78. That's 78 plus 160. 78 plus 60. 160, I mean. Oh. 238. 238. Meaning on this side we should have 78. Oh, sorry. 160. Which will give us 238 grams per mole. It's balanced there. Did you see how I verified that I balanced correctly? Now guys, please, just to wrap up. So today we learned about equations and how balancing chemical equations, which chemical equation or the chemical, we deal with how new substances are formed and everything, and how we wanted to maintain the left hand side being equal to the right hand side, and how we can verify that using the periodic table. So use, guys, the periodic table, study the periodic table, know the periodic table. Another thing that you need to know is that how do you convert from H2O? For example, if you're given water, you know that the chemical formula for water is H2O, right? So you need to know that from the name to the chemical formula. So guys, as I said, I'm a very truthful teacher, you know that. I said that I'm gonna give you your pizzas and your fast food. So now guys, sometimes you do not have to think inside the box. So you need to think outside the box. Think about how fruitful or how delicious your fast food is, right? Now, we have two meanings. It's a literal meaning and a figurative meaning. So now, figuratively, I'll be giving you your fast foods. What do I mean? I mean that, don't frown, guys, don't frown. And please don't wait for me at the gate after school. You said, sir, you're gonna give us our pizzas and everything. Guys, I just need you to write this down and you'll just do them for homework. That's your fast food. Isn't that interesting? Sir, but sir, it's fruitful though. It's fruitful. Plus O2 ZNO plus. Can you see this? SO2. Are there any questions, guys? Oh, another one. Let me just give you the last one. It's hydrogen gas plus oxygen to give me water. Remember the Fantastic Four? Remember the boxes? Remember the multiplication? Guys, I want to love and leave you. It's been fun. It's been great. You need to have lunch. You need to eat. Probably hungry. So I'd like to thank you, and we'll see each other tomorrow. Please do eat the fast food. Meaning, please do the homework. Thank you.